Good evening, students.
Savings.
Shall we start? Hello, shall we start? Am I audible, Pa? Students, am I audible?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So last class where we stopped? Where we stopped? So remember or forgot? Which place we
Organic
stopped?
chemistry,
Now?
sir.
Yes.
We're looking at organic chemistry, sir.
Organic chemistry only. Where? Which chapter? Which one we started? Which one started? Ravigaran?
Functional group, sir.
Yes.
Functional group, sir.
We started function. Right.
Functional groups, sir.
Okay. So what is the functional group of aldehyde? All of you. Just answer my question. What is the functional group of aldehyde? What is the functional group for aldehyde?
Sir,
Yes.
C double bond O, then a single bond H, sir, with C, sir.
C double bond O and single bond H.
Sir.
Okay. What is the amide functional group?
Sir,
What is amide? Amide.
double bond O, sir, then a single bond NH2, sir.
Double bond O.
Single bond NH2 with C, sir.
CONH2, right? CONH2 only you are saying. Am I right?
Yes, sir.
Okay, good. Okay. Now we are going to see. So you have the nomenclature of naming the organic compounds. So far you have studied in 11th, 9th standard, 10th standard to name the organic compound. Today we will go by other things. Okay. Later we come to that. When you are solving the problem, that time we will do that. Which one? The nomenclature. Now we'll go to the directly topics, concepts. Okay. Shall we go for concept or nomenclature? Which one? Tell me. Which one will go? Which one will start, ma? So that class we seen that aliphatic compound, aromatic compound, benzenite compound, non-benzenite compound. Those things we completed, huh? Hello.
Yes, sir.
We completed the types of organic compound. Organic compounds
Yes,
are
sir.
open chain, that we completed. No, that example also we have completed, right? Now, so we started a functional group, and then now we'll go for the homologous series. What is the meaning of homologous series? What is a homologous series? Why it is called so? So
It has difference of CH2 group.
it will differ by one by other by CH2. Good. Then, so if you are taking a alkane, the continuous two, methane and ethane, if you are taking, the difference is CH2. Ethane and propane, CH2. Propane and butane, CH2. So if you have a characteristic functional group, the adjacent, the next compounds, the number of your homologous series can be represented by the general formula. For example, CnH2n plus 2 for the alkane, CnH2n alkene, CnH2n minus 2 alkynes. Likewise, we can say that. Okay. So now, so those types compounds are called homologous series that can be prepared by the general methods. If you are preparing by the decarboxylation method, means first compound, The second compound also we can prepare by decarboxylation method. So this is known as homologous series. So example, alkane, alkene, haloalkanes, alcohol, ketones. So it will be example for the homologous series. And then nomenclature of organic compounds. Okay, that I will skip today because many of them are not joined. Okay, we'll go to the isomerism. What are the types of isomerism? So will you see that what I'm writing?
No, sir.
Just a minute. I will- So the organic compound. So I'm writing. Could you see?
Sir.
All of you could see my video?
Sir.
I think yes.
Yes, sir.
Okay. Now, the organic compounds. So that day we have discussed the classification and all. Today we are going to see the isomerism. I will teach you the nomenclature next class. Okay, tomorrow we'll complete today isomerism because short time we will complete this portion today. Isomerism. Generally, the isomerism are able to hear my voice, right? Say yes or no.
Yes, sir.
Okay. So the isomerism, what is isomerism? Iso means same, mes means solid. Okay. So when you have same molecular formula, different structural formula are called isomerism. Same molecular formula, different structural formulas are called isomerism. Now, this isomerism can be classified in two types. One is constitutional or structural. Another one is configurational. So what is isomerism? Isomerism means same molecular formula, different structural formulas are called isomerism. So it can be classified in two types. One is structural isomerism. Another one is stereo or configurational isomerism. Stereo isomerism or configurational isomerism. Now, this structural isomerism can be further classified into many types. One, chain or nuclear isomerism. Chain or nuclear isomerism. Number two, position isomerism. Number three, functional group. Number four, metamerism. Number five, tautomerism. So, position isomerism. Next one, functional group isomerism. And fourth one, metamerism. Fifth one, tautomerism. Tautomerism is a type of isomerism, but it will exhibit only some of the compound. That's why. Then configurational isomerism, again, they are classified into conformation, stereoisomerism, and classify conformation and configuration. The configuration isomerism will give two types. One is geometrical, another one is optical. So with this, we are going to see many story about this. Why? So beauty of the compound, organic compound, it exhibit isomerism because it shows like a same compound, but it has a different properties. Why it has different properties? For example, you are seeing that carbohydrates. Carbohydrate, we are saying D carbohydrate and L carbohydrate. What is difference between D and L? When you are taking amino acid, it becomes D amino acid and L amino acid. When you are seeing the tablet backside, the ingredient, they will mention D glucose, D fructose, or L amino acid, L proline, L something. When the amino acid means, they will designate it with capital L and small d or R or S. Like that symbol will be there. Okay. So it means it has the same like compound, but the different configuration. That is the meaning. Same way, when you are taken a CH2O or C2H6O. When you have the molecule C2H6O, so what is the difference when you are seeing? So I am writing the example C2H6O. It's a molecular empirical formula. I am writing it in here CH3O CH3 and CH3 CH2OH. Look here, both are having 2 carbons, 6 hydrogen, 1 oxygen. 2 carbon, 6 hydrogen, 1 oxygen. So what is the difference? But their physical property is different. This physical property is different. When you are measuring the mass, you can be able to get the same mass. For example, 2 carbon, 6 hydrogen, 1 oxygen. What is the mass? That mass only you will get for both this. The pattern will be different. The next story that will be. But these two having the same molecular formula. When the molecular formula is same, but the different structural formula means it is called as constitutional isomerism. Constitutional means how it was connected and where it was connected. That is constitutional or structural isomerism. So that can be classified into chain, position, functional group, metamerism, and tautomerism. So what is the meaning of chain isomerism? When you are writing that, when you take an example, so you take that C4, H10, then I'm writing CH3, CH2, CH2, CH2OH. 1, 2, 3, 4 carbon, 5, 7, 9, 10 hydrogen, and 1 oxygen. There is no doubt about it. But the same thing, CH3, CH, CH3, CH2. So one of the carbons, I put it in the branch. Then the name of the compound become 1, 2. So for the naming nomenclature, what we will do? You have to choose a longest chain. So you have to give the preference for the functional group. When you are giving the numbering, you have to give the preference for the functional group. When you are choosing the number 1, 2, 3, like that, or 1, 2, 3, like this. Suppose if you are leaving, you will get the same only. That's why I have given like that. So look here, for the first carbon, there is no attachment, but here you have OH. Then you have to give this naming. So the first carbon OH attached, second carbon, you have the methyl group. So 2 methyl, 1 propanol is the IPACN. But this is called 1 butanol. 1 butanol, 2 methyl propanol. So both are having the same molecular formula, but their structures are different. By changing the chain, அதாவது the carbon nuclearல attach ஆயிருந்த ஒரு carbon மாறி attach ஆனதுனால இது மாறி இருந்தது. So this type of isomerism will lead to give the position chain or nuclear isomerism. Nuclear isomerism, it goes like a chain. That chain you are changing into the branch, then it is called nuclear or chain isomerism. Somewhere it will be nuclear, somewhere it will be a chain isomerism. I think your book they are given chain isomerism, but nuclear isomerism also one of the name. And then coming to the position isomerism. Position isomerism means you take the same example. Now, if you are giving number 1, 2, 3, 4, 1, 2, 3, 4. So OH is the functional group. So you have to give the number to be 1. So this is called 1 butanol. The same compound I am writing into CH3, CH, CH, CH3, OH. Now what happened if you are giving number like this 1, 2, 3, 4, 1, 2, 3, 4. So bottom one you will choose because 2 only attached. So the name of the compound is 2-butanol. 1-butanol and 2-butanols are different. Both are alcohol. Clear? Both are alcohol only, no? Say sir, no?
Yes, sir.
Both are alcohol, right? Hello, சொல்லுங்கப்பா எஸ் இல்ல நோ ஏதோ ஒன்னு
Yes,
சொல்லுங்க.
sir.
But it differ the OH position. That's why it is called position isomerism. That's why it's called position isomerism. Same way, when you can say that we will discuss one by one. That will be better. So now what we are discussing, position isomerism. We will take many examples and then we'll do it. So for the position isomerism, CH3, CH2, 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 CH2OH. Now you name the compound. We'll learn from here also, no problem. So totally 1, 2, 3, 4, 5 carbon is there. You give the numbering 1, 2, 3, 4, 5. So this is the functional group. Don't forget 1, 2, 3, 4, 5. So definitely you have to choose the bottom one. So the OH are attached in the first carbon, and then 5 carbon is there. 5 carbon means you know that 1 carbon means meth, 2 carbon means ether, 3 carbon means propane, 4 means water. 4 means what?
You
5,
and
6,
X.
X, 7, heptane, 8, oct,
Oct.
9, non, 10, dic. Okay, wow. So this is how we have to say the compounds. Now, why I am leaving the last one means alkane means it end with A and E. Alkene means it end with E and E. Alkyne means it end with Y and E. So this is how we know that. So it has a 5 carbon. So it is a 10. The alcohol attached in the first position, pentanol, OL. The alcohol name end with IUPAC with OL. Okay. Suppose if you are putting AL means that will be aldehyde. That will be a aldehyde. We have to very careful when you are writing the IUPAC name. One pentanol. The same thing. I am changing CH3, CH2, CH2, CH, CH3, OH, CH3, CH2, CH2, CH3. So now we have seen position isomerism and chain isomerism. You tell me which of the structure will show the position and chain isomerism. So now first you name it, the compound. Could you see that red color also, no? You name, what is the name of this compound? What is the name of this compound? Murali? Naveen?
Sir, pentatonol.
This one?
Yes, sir, that one.
What is the name?
Pentatonol.
Pentanol. Pentanol. 2 pentanol or 1 pentanol. 1 means it was in the first position. This was in the second position. And coming to the third one. So you have the structure 1, structure 2, structure 3, structure 4, structure 5. You tell me what are the compound which shows position and then chain isomerism. Quick, first. Yes. Hari Raghav.
So 3 pentanol.
3 pentanol. So if I call the name only, you will tell, nah? Then Catherine, could you tell the fourth one? This one. CH3, CH2, CH3, CH2OH.
I don't know, sir. I'm not sure.
Why?
Sir, it's placed in third position, but then it's
Uh.
not OH, no, sir.
No problem. You just name it.
4 pentanol. I mean 3 pentanol, but then CH is placed in the third
It's not,
position, sir.
it's not a 3 pentanol, just to give the naming. So you have the alcohol means it will be 1, 2, 3, 4. And branching also you have to give the chain 1, 2, 3. So you have to choose a longest chain. That's why it will be a number. Okay, when you are having means you have to call like this. So you give the number 1, 2, 3, 4. And the second question it was attached methyl group. And the first question was alcohol. So which is the primary functional group? Alcohol is our primary functional group. So whatever attachment is there, first you have to mention 2-methyl. Only 1 methyl group is there, no? That's why you are mentioning 2-methyl. Remaining how many carbon is there? How many carbon, ma?
4, sir.
So 4 means butanol. If now you have alcohol in the first position, so 1 butanol, but the second position you have
Can you come again, sir?
second position you have what group?
CH, sir, is it 3 or 2?
CH3. CH3 means what?
Sir, yes, sir.
So 2-methyl 1
Butanol.
What is the name? This is 2-methyl 1-butanol. And Srinidhi, will you try the fifth one?
Sir, is it 2,2 dimethyl propanol?
Very good. 2,2 dimethyl propanol. Propanol means you can second position to methyl group. So no problem. Definitely OH will be in the other first one. That's why we are not given one propanol. Huh? So now you tell me which are the structure will show position isomerism and which are the structure will show chain or nuclear isomerism. It will show only these two. You tell me.
Sir, 1, 2, and 3 show positional isomer.
These three are
Position.
position isomerism. Okay. What about 4 and 5? Sham? Sham,
Yes, sir.
tell me. So these three are position isomerism. What about these two?
Sir, can you repeat the question, sir?
So among the 5 structure, which will show position isomerism, which will show nuclear isomerism, nuclear chain isomerism. Now only you are listening the question. Huh?
Sir, 5 is chain isomerism, sir.
Okay. With what? This 5 with 2 or 5 with 3 or 5 with 4 5 with 1
Sir, 5 with 1 minute, sir.
So other person can try no. Stay up. Quick.
Sir, is it 5 with 4?
5 and
4.
5 and 4 sir. Please tell me 5 and 4 sir. Which isomer? Huh?
Structural isomers.
இது எல்லாமே ஸ்ட்ரக்சர் ஐசோமர்ஸ் தான்.
Sir, 4 and 5 are chains, sir.
Chain isomer. 5 and 4 are chain isomers with the 1. So when you are writing the first structure, you are writing second and third, it gives a position because the functional group position only changing. Okay. Whereas when you are seeing the first, fourth, and fifth, you have changed in the number of carbon. When the number of carbon changed, but the same molecular formula, same molecular number of carbon, number of hydrogen, number of oxygen should be same. So if you are thinking the 5 carbon, the 5 structure, all the 5 structure having the same molecular formula. There is no doubt about it. But the difference is 1, 4, 5 is number of chain only, number of carbon, the variation. So here you have 5 carbons are connected. Here the 4 carbons connected. Here 3 carbons connected and 2 carbons are branched. Here 1 carbon is branched. Coming over here, the OH only change the position 1 into 2, 2 into 3. So that's why it is a position isomer. It is a functional group isomers. Okay. It's a nuclear isomerism or chain isomerism. This is called position isomerism. Next, we'll see the functional group isomerism. So the functional group also can have the isomerism. What are the things will give the functional group isomerism? We'll see. Functional group, alcohol will have functional group isomerism with ether. Aldehyde, functional group isomerism with ketone or enol. Ketone have functional group isomerism with enol. We'll see. Simplest, then we'll go each lesson, we will learn it. Now, what is the functional group isomerism? Two or more compound having the same molecular formula, but the different functional groups are called functional group isomerism. So this is, we are call it as functional group isomerism. For example, you take C2H6O, C2H6O. You can write CH3, CH2OH. What is that? What is this? What is this, ma? What is this? CH3, CH2OH. OH means alcohol, no? Then what is the alcohol name? 2 carbon is there.
Ethanol.
Ethanol. Then CH3O, CH3. Look here. CH3O, CH3. What is the compound? What is the compound? CH3O, CH3. What is the compound? What is the compound?
Sir, a video is not
Enema?
yes, sir.
CH3O, CH3. What is the compound? So this is you told ethanol. If you have the functional group, the oxygens are bridging between two alkyl or any organic compounds, then it is called what? Yeah. What is this? Ether. You forget, huh? So ether, which is having functional group isomerism with alcohol. So look this, you count the number 1, 2 carbons, 6 hydrogen, 1 oxygen. 2 carbons, 6 hydrogen, 1 oxygen. So when you have the ether, definitely it have the functional group isomerism with your alcohol. So you take C3H6O. C3H6O. Now you can write the formula CH3, CH2, CHO. This is called aldehyde. CH3, CH2, CH2, CHO. Then CH3, CO, CH2. And this is called ketone. This is aldehyde. This is ketone. So aldehyde and ketones are functional group isomerism. Okay. Is it okay?
Yes, sir.
Then next, metamerism. Metamerism only can happen with the ether functional group. When you have the ether like functional group, so you have two groups are attached in the both side of the oxygen atom. One side will be having higher and one side will be having lower, means then it is called metamerism. For example, C4H10O, you can write C2H5, sorry, CH3. For this, we can write CH3, CH2O, CH2, CH3. This is called diethyl ether. Okay. Suppose one of the carbon going that side, CH3, CHO, CH2, CH2, CH3. So both are having the same molecular formula, but the number of carbon attached on both sides of the oxygen will be different. This type of isomerism is called metamerism. So it arises due to the difference in the alkyl chain on either side of the functional group. So it is known as metamerism. And then I told you one more thing, stereoisomerism. Stereoisomerisms are whatever we have seen.
Atomerism.
What?
Sir, you forgot atomerism.
No, I'm not getting your voice. Please pardon. Please pardon. என்ன கேக்குறீங்க? Tautomerism. Tautomerism is a migration of, it will exhibit, okay. It will exhibit only certain compounds only, that is known as tautomerism. I will correct, thank you. Tautomerism is a migration of labile hydrogen atom from one atom to another more electronegative atom in the same molecule is known as tautomerism. So it exhibits keto-enol tautomerism, nitro-acinitro tautomerism, and amido-imidol tautomerism. When you have your keto group, definitely it will exhibit enol form. Suppose if the keto group is attached with CH2 group. Same way, nitro group is attached with CH2 group, means it will exhibit acinitro form. Amido group is there, means definitely it will have the imidol. Look here, when you have the ketone, so what is the name? Propanone or acetone. Okay. So what I said, what is the tautomerism? Migration of labile hydrogen atom from one atom to another more electronegative atom in the same molecule. So it will exhibit in the same molecule, but the hydrogen shift will be shifted. Please remember, this is not the different compound, but it exhibit. That's why we are saying it's isomer. So look here. So one of the hydrogen. So when you are writing like this, means CH3. So what happens? This hydrogen goes to like this, and it will give. So what happens? CH2 double bond C. OH and then CH3. So here you have the keto group. Here in the double bond and OH is there. That is why keto-enol tautomerism. Puridama? This is called keto-enol tautomerism. And then nitro-acinitro. You have the nitro group. Okay, then same way, hydrogen go like this, it will go like this. Then it will be CH2 double bond N OH single bond O. Here you have NO2, here NOHO. So this is called acinitro. So what is the meaning? Migration of labile hydrogen atom from one atom to another more electronegative atom. So among the oxygen is the more electronegative atom. So that's why here 1, 2, 3. So 1, 3 shift. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 1, 2, 3. 1, 3 hydrogen shape. First portion and the third portion. At amido. CONH. So what happened? Gives okay. So this is called tautomers. Is it clear? Okay. Okay, wow. Is it okay, ma?
Yes, sir.
So this is called tautomerism. And then the next one is stereoisomerism. Stereoisomerism means when you are looking this, see, you can see that molecule like this tetrahedral molecule. Okay, in the 3 dimension, look this. Could you see the color, ma? Whatever color I am showing. So this will be some blue in color. This is blue color, and this will, it shows some red color. Back side you have full red. Okay, so let's go. You could find the 4 colors, different 4 colors. Correct? Could you find the 4 different colors? Could you find 4 different colors? So this were somewhat different color, red, blue, and then white. You consider like this. Now I have chosen 2 V's, correct? So 1 V and other 2 V. So when you are putting like this means you will have like this. Okay. Now the 3 dimension, it was oriented in this direction. It was oriented in this direction. This was upper side. This was back side. Suppose if you are changing these 2, what happened? These 2 not change, but these 2s are changed. So when you have the carbon which is having 4 different groups, when it is arranged in the space, it gives rise to stereoisomerism. The stereoisomerism can arise due to carbon-carbon bond rotation, or in the optical isomerism, or carbon-carbon double bond. So that type of isomerism is known as stereoisomerism. Stereoisomerisms are nothing but they are connectively same, but structurally same, or constitutionally same, configurationally different. For example, when I am writing so I'm writing OH over here, CH3 over here, and CHO over here. CHO hydrogen I'm writing like this. When you have the compound like this means it will be rotate. It will rotate. So இந்த பார்க்கும்போது ஏதாவது டிஃபரன்ஸ் உங்களுக்கு தெரியுதா? இந்த ரெண்டு காம்பவுண்டையும் பார்க்கும்போது what is the difference you are observing? What is the difference you are observing? Huh?
CH3 is placed, sir.
CH3 is
Displaced. Here it is in the left, that's on the right.
it's not displaced. Everything attached to the same carbon only, correct? The carbon which is attached to CHO, which is attached to hydrogen, which was attached to OH, and which was attached to CH3. Same way the carbon is attached to CH3, OH, H, CHO. The connectivities are same, correct? Molecular formula same. Am I right? Looking here, all the molecular formula same, connectivity same, but the configuration is different. One configuration coming anti-clockwise, other configuration going clockwise. So why it exhibit this type of isomerism? So in the space, what is the difference? In the space, how the two groups are oriented, how the four groups are oriented, which can give rise to the isomerism. For example, you can write C double bond C HO CH3 HO CH3 C double bond C you look this compound. When you have carbon-carbon double bond, the hydrogens are the two hydrogens are opposite. Two methyls are opposite. Whereas here, the two hydrogens are one side and two methyl groups are one side. So this type of compound have the same connectivity. பாருங்க இந்த கார்பனை பொறுத்த வரைக்கும் ரெண்டு கார்பனோட அட்டாச் இருக்கு. Two carbons இருக்கு. One hydrogen. இதுவும் பாருங்க 1 2 hydrogen. 1 2 1 2. It was same attachment. Okay, same attachment means it was attached with the hydrogen, methyl, and carbon-carbon double bond. There is no doubt about it. But this is the different compound. This is the different. Same way. This is the different compound. This is the different one. Okay, what is a stereoisomerism? Stereoisomerisms are isomers which arise the groups which are oriented in the space, which can give rise to the isomerism. That is known as stereoisomerism. And this stereoisomerism can be classified into optical and then geometrical. So that optical geometrical, when we go to the topic, we'll discuss detail. Okay, whenever the lesson coming now, that time we will discuss detail. And then if you are studying organic reactions, okay, any organic reaction you are studying means, so some of the reagents coming and attacking your starting material, it gives rise to product. How the product is forming, how the electrons movement is occurring, that we are progress through the mechanism. Okay, so whenever you are seeing the organic reaction means what is the starting material, so what is the nature of starting material, whether it is electrophile or it is a nucleophile or it is a free radical, then how the reaction is going. So starting material or substrate which attacking reagent, it gives to the intermediate. The intermediate can give the products or byproducts. That is known as organic reaction. So whenever you are thinking the organic reaction, it takes place. Organic reactions. We are coming to the organic reactions, type of organic reaction. So the starting material with the reagent, it gives intermediate. This intermediate, it gives product or decomposed or it gives byproduct. So everything based on the reagent. When you are looking the electron movements, it is known as mechanism of the reaction. Okay, so first, each bond is consist of 2 electrons. You don't forget that. Okay, each bond is consist of 2 electrons. Either it is called, mostly organic compounds are covalent. Okay, so covalent bond means mutual sharing of electron between the atoms. It gives the covalent bond. Now the cleavage, types of cleavage, when you are having bond A and B. Okay, when it will undergo 2 types of cleavage, you are going to break the A and B. Okay, so how the A and B is a break? So first is homolytic and the second one is heterolytic. Homo same, hetero difference. Okay, when the homolytic, heat or light or heat, when your compound is having same electronegativity. Okay, for example, you have the chlorine or a hydrogen, bromine, in the mari வந்து same molecules are இருக்குதுன்னு வெச்சுங்களேன். When you are exposed into the light or heat, it will give, so what will happen, it will cleave like this. Please remember, when you are putting the symbol with the one side arrow means it gives 1 electron. If you are putting the symbol with the 2 double-headed arrow means it gives minus 2 electrons. It will take a pair of electron, meaning whenever it started, no, that side it become plus charge. So when you are curved arrow you are putting, when you are starting that curved arrow, it become positive. So if you have the double-headed arrow, it is a negative with the pair of electron. Okay. Okay, clear? Say sir, no. Suppose if you are putting single-headed arrow, then it is a radical. So it gives A dot plus B dot. So it carries one electron, then it is called free radical. So this. So the atom which has an odd electronic species, then it is called free radical. Okay? Okay, va? Say sir, no.
Yes, sir.
No, suppose if the A and B electronegatives are different, A and B electronegatives are different, so then it gives rise to two different cleavages. So A and B, when it cleaves, suppose B is more electronegative. Negative means what will happen? You take a pair of electrons, it gives B minus and then A plus. A plus is a cation, B minus is an anion. It has A dot B dot. It's a free radical. In case A is more electronegative. So what will happen? A with B. The A will take a pair of electron and B will be a positive charge. This is called heterolytic fission. Okay? Okay, ma? So what is homolytic fission? What is heterolytic fission? Purida? Is it clear?
Clear, sir.
Okay. I think you can up to this today we can close. Yeah, because now you have the max class, no?
Yes, sir.
Now you can leave and go join the class. Math class.
Thank you, sir.
Thank you, sir.